Hello, this is Alan Elliott with SAS Essentials, Mastering SAS for Data Analytics, 3rd edition. This is Chapter 5, Preparing to Use SAS Procedures. In this chapter, we're going to learn about SAS Support Statements, the title and footnote statements, including comments in code, the run and quit statements, how to use SAS PROC statements, the var, by, and ID statements, label, where, PROC print, and also how to use common system options and how to split column titles. As we've mentioned before, to do the hands-on examples, please make sure you have the proper downloaded files to follow along. So let's begin. This is section 5.1, Understanding SAS Support Statements. We're going to start by looking at the title and footnote statements. These statements allow you to put explanatory comments at the top or bottom of your output, their titles and footnotes. You can actually have up to 10 lines of titles, as we're going to see. The way that you do this is with the title statement and the footnote statement, and they follow this format: title, and then in quotes, either single or double quotes, whatever title text that you want. Or it's the same with footnotes. The way that you have multiple titles is you can have title N, which N can go from 2 to 9. So you can have title 2, title 3, and also for footnotes. So let's see how that works. So here's an example here where I have title, which is the first line of the title, then title 2 is the second line. Title 5 skips several lines and then has a title, footnote, and then footnote 3 is a footnote on line 3 of the footnotes. Now, it's usually a good idea to have at the bottom of your program just the word title, semicolon, and footnote, semicolon. When you create a title, like is at the bottom of the program here, if you create a blank title, then everything below that, title 2, title 3, whatever, is erased. And the same thing for footnote. So this statement, these two statements at the end, erases all the titles and footnotes. And the reason that's can come in handy is if you define a title, then SAS remembers it from one example to another. So if you happen to run a program with a title and then run another program, SAS will remember that title unless somehow you get rid of it. And that can be confusing because you have the wrong title on some output. Okay, let's do hands-on example 5.1. In this case, open up the file called dtitle1.sas. And let's look at the code here. We're reading in a file called example.dat, and we have a PROC print where we have defined 3 lines of a title, title, title 2, and title 4, plus a footnote. Then in PROC means, we redefine a title 2. If you recall, when we define a title, like title 2, it will erase anything below that. So title 4 then would go away once we define a title 2 in PROC means. Let's see how that works. Okay, so here's the first part of the PROC print, where we define the 3 titles and a footnote. So you'll notice here we have a line 1, 2, a blank for 4, or 3, and then using the example data set, that's the 4th line. And then we have a footnote. All right, now, when we do PROC means and define a title 2, this is output from PROC means. Notice that appears in the second line. It preserves the first title, gives us the second title, and then erases all the other titles on line 4. The means procedure, that's just part of SAS's output. So title 4 now is gone. So let's look at customizing titles and formats. So we can not only output titles and formats, but we can also do some things with them. Like in this example, we can cause the title to be blue with a height of 5. The normal height is 1, so this is going to be a larger one. Notice that this appears before the actual text of the title. So this will influence what this turns out to be. All right, here's an example. Example 5.2, open the file called dtitle2.sas, and you'll see this, this code here. Notice in this title, I'm doing a lot of things here. I'm going to justify it right. I'm going to use the font called Swiss. I want it to be red in color, bold, a background color of yellow, and then some text, example. Now I'm continuing on the same line. I haven't done a semicolon yet. I'm going to change my color to black and bold and italic, and I'm going to say today's date is, and this is going to print whatever today's date is. Then in title 2, I'm going to justify its center. I'm going to use a strange looking color here that we'll define in just a minute, which happens to be brilliant blue. And then the footnote, I specify some various heights, as we're going to see in the output, and I'm also going to underline some stuff. So let's see how that works. Run this program, and we should get this kind of output. Notice here I have example is red, yellow background. I changed it to red, black italics. There's today's date. The next line is brilliant blue, and there's the footnote underlined with several different fonts. So you can play around with your titles to make them do whatever you want to do to make your report stand out. So let's continue with example 5.2. After running the program and seeing how it turns out, go back to the editor and make these changes. Change the justification from right to left, color to red, color from red to blue, background from yellow to light gray, and whatever other changes you might want to make. Run the program just to see how it's pretty easy to change all the items there. There's some other things on the examples that you can do from the text. Encourage you to do those. And here's a table with common options for titles and footnotes. We've seen most of these, like the color. One I want to mention is the C equal RGB code. You'll notice in the explanation there's a C equals CX803009 for reddish orange. What that is a lot of times companies, corporations, or organizations have a particular color that they have as defined as their color. And they oftentimes want things to be in their color, so you can specify a very specific color if they can give you the RGB code for that color. You can choose a background color, justification, and so forth and so on, as you see there, and we'll see some examples of that as we go along. It's also a good idea to include comments in your SAS code. This allows you to put information in your code so that when you go back 6 months later, you can tell what you were doing, or maybe someone else doing your is using your program can hopefully figure out what you've done. There's two ways to do the comments. The first is by putting an asterisk and then typing in whatever message you want and ending in a semicolon. As you can see there, it appears as green in the editor. I often like to box my messages, like the example here, starting again with an asterisk and ending with a semicolon. You can also put a comment on a line that is a coded line, like data, my data, and then you can just put a comment there on the line, again using the same procedure. A second way to do a comment is with the slash asterisk and end with an asterisk slash. The reason that this comes in handy is that when you use this, SAS will ignore even any code or semicolons that you have within the comment section. And this comes in handy when you want to maybe comment out a section of code that you've done, maybe as a test code, or you've already used it, but you want to preserve it in somehow. Then you can use this to comment out sections of code. Using the run and quit statements. We've seen the run statement appears at the end of all or most of our programs. The one we haven't really seen is the quit statement, but that comes in handy sometimes because there are some procedures that basically continue to run even with a run statement. So, for instance, if you do a PROC reg, which is regression, and you don't have a quit statement, you may see at the top of your screen it says PROC reg still running, and so it has that ability for you to actually give it more information and continue to do things. And so we want to put the quit in the program to actually cause it to stop. It doesn't hurt to have the quit in your program anyway, if you're not sure whether it needs it or not. All right, so let's look at the syntax of a PROC statement, and we're going to look at this in several ways, but basically it's PROC name and then some options, semicolon, and then statements and statement options. Let's define that more thoroughly. So here we have PROC name, the name of the procedure. Options appear before a semicolon, and then we have statements appear after the semicolon as a separate phrase. And then sometimes there are statement options that follow a slash. So you see there that there's sort of four components to a typical PROC statement. All right, let's look at the then as an example, PROC print, where we have data equal my data. That's an option. It appears before the semicolon, and we've seen that before, so that's no surprise. Then we have a statement. And here's an example of a statement. Again, we've seen this before, where we have PROC print, data equal my data, semicolon. So that ends the PROC, that ends the options. And then the var statement then specifies which variables we want to be output with PROC print. Now there are some other ways that we can define these variables, and we'll see that in a minute. But here's another example of a statement in a procedure. So here's PROC freq, which is a frequency procedure. And again, we have data equal my data as an option. And then the table statement is unique to PROC freq, where we have group by socio / chi-square. What that produces is a table of counts of group by socio, a cross-tabulation table, and then it does a chi-square analysis. So we can see we have then a statement and then a statement option. So again, let's sort of drill down into this. We have PROC freq is the name, the option you see there, and then we have the PROC statement, which is group by socio, and then the PROC statement option. All right, let's look at some of what these options and statements are. The options at the top of this table we've seen before, the data, and then the out we've seen for PROC sort, for instance, creates an output file. The statements, we've seen some of these, the var statement, the by statement we saw used in PROC sort. We're going to look at an ID statement in just a minute. We've seen the label statement and how it works, create a label, and then also we'll look at the where condition in this chapter. So let's look at options specific to a PROC. So sometimes a procedure will have some options that are really only used for that procedure. And so this is an example of that, where we have PROC means. One option is data equal, and then there's a second option we have here. Notice it's within the semicolon, so it's still an option, max des equal 2. And what that tells it to do is output the numeric values with 2 decimal points. Now let's look at using the var statement in a SAS procedure. So we've seen the var statement before, and so here's an example of it, where we have the PROC means and we have the var statement as we've seen before. But the point we want to make here is that there's some other ways that you can use the var statement. And one of them is if we have consecutive numeric suffixes, such as Q1, Q2, Q3, then we can actually use a sort of a shortened code for indicating the variables there. We don't have to list them all. We can say var Q1 dash Q50 means include all the variables between Q1 and Q50. Similarly, if we don't have consecutive suffixes, then we can say var dash dash var some variable dash dash some other variable. And what that says is include all variables between, in this case, ID through time 4 and everything in between. And then let's revisit a little bit of the by statement. So we saw the by statement used in PROC sort, where we read in a data set, for instance here called some data, and we output a data set called sorted. And the by statement, by group, tells PROC sort which variable to sort on. It could be age or group value or something like that. Now, that's part one of how to use a by group. The value of this, once we sort it, is we can use it now in a procedure to create sub-analyses. So if we do PROC means and then have a by group in it also, what it's going to do is it's going to do the PROC means for each group that we've indicated here. So let's say if group is A, B, C, D, it's going to do produce a table for A, B, C, and D, whatever groups match that, that designation. And so here's an example, 5.3. Open up the file called dsort means, and this is the file that we sort of saw before. We're going to open up or we're going to use a file called example and read in the data. And we're going to do proc means in two ways here. The first time, we're just doing a plain ordinary proc means. Proc means var time 1 time 2. Then the second time, we're going to first sort the data. And so we do a proc sort, data equal my data, out equals sorted by group. Now the proc means is going to use that sorted data, so data equals sorted. And notice here we have the by GP statement in here. So what that's going to do is, as we mentioned, that's going to produce tables, the proc means tables for each value of GP. So here are the results. So you can see the top table is all the data, the regular proc means that we did, where there's 50 records in the data set. And then the second one is where we did the, as for the data analysis proc means by group. In this case, notice we get group A has 11 observations, group B has 29, and so forth, however many groups there are. Now let's continue with this exercise just to show you that it's easy to manipulate this and get the subgroup analysis you want. And so let's, in the proc sort and the proc means, change the GP variable to status. So we're going to make that little change. I think there's only 2 changes that you need to make, and then run it again, and you should see now this output. And you see now we have 5 different tables that is created, each one for each value of status. So again, there's some other options in this hands-on example. Go ahead and complete those as given in the text. All right, now let's look at section 5.3, using the ID statement in SAS. Now the ID statement provides us a way to sort of increase the readability of our output. It tells SAS to use a specific variable as the observation identifier rather than the OBS column, which is the normal column that SAS will output, for instance, in PROC print. So here we have two versions of a program, of a PROC. We have PROC print, just normally, and now we have PROC print where we have ID, some ID. So this tells you that you can add this new statement to PROC print to do something different. In this case, replace OBS with another ID. So let's look at that. Open up the program d_id.sas. This is example 5.5. And notice that we're reading in a data set that has something called rat ID in it. So this is the ID number we've assigned for the various rats, 1, 2, 3, 4, 6, and 8. And at the beginning, so far, we're just doing a PROC print. So this is just a normal PROC print that we're doing on this data. And we notice it appears here at the top. We see that the OBS column in the far left, OBS 1, 2, 3, 4, that's the normal PROC print that we get. However, if we change the PROC print, where we have PROC print data equal weight, ID, rat ID, so we're specifying an ID, then what it does is it changes that left column to rat ID. So it creates a much more readable column, particularly if we're wanting to concentrate on information by some ID. So that becomes handy. Again, just another way for you to manipulate your output, maybe to make it more readable. All right, section 5.4, using the label statement. And again, we've seen the label statement before, but we'll take a little deeper look at it, where we have label var equal label. And in this case, we're doing the PROC print label, again with the ID, and then we're saying label TRT equal treatment. I want to point out again that if you're wanting a label to appear when you're using PROC print, you have to use that option label in the procedure. Otherwise, the label that we create will not appear as one of the column names. So let's look at that as an example. 5.4. Open up did.sas. You probably already have it open. And we're going to change the code around a little bit. This time we're going to do proc means data weight label weight underscore grams equal treatment, and then mdate equal med obs date. So we're creating two labels there. And now when we run that, notice how it's going to produce this output. Notice that we have a label column where we have med obs date and treatment. So if we didn't have, if we did the proc means without a label statement, it would not produce this, this label column here. All right, let's look at section 5.5, using the where statement in a SAS procedure. The where statement allows you to specify a conditional criterion for which the output will be included in analysis. That's a fancy way of saying you can choose which data you want to be used in an analysis by specifying some sort of restriction. So for instance, where TRT equal A says only use the data where the treatment variable is equal to A. So that'll, another example might be where gender equal M or something like that. That would produce an analysis only for males, which again is a way to do some sort of a subset analysis easily. All right, here's an example. Using again the previous hands-on example of 5.4, make this change in the program where we have proc means data equal sorted, var time 1, time 2 by status and run. Now that produces a proc means for all the data. However, if we add the following statement after the by statement, so we have by status, then we have where status less than 4, and rerun the edited program, we're going to see that it limits the data that is output. In this case, we said, again, status is less than 4, so we only get the tables for status 1, 2, and 3. So again, we've limited the data that's used in this analysis. All right, hands-on example of 5.6. Again, we're going to use the same program and just to alter the program again a little bit. Let's do a PROC print label with data equal weight. We have the ID and we have the label statement there for treatment. Now we're going to say where treatment equal A. Now when you run that, you get this output here, and we see again we have the rad ID and all the other things. But notice here only the data where treatment was listed as A is included in the output. Again, a way to do some sort of a subset analysis or subset report by limiting it with the where statement. All right, so let's look at some common options for PROC print. We've seen some of these, but some of them we haven't. We've seen data equal data set. One we haven't seen is double. What this does is double spaces the output. If we're using something like Word or PDF output, it doesn't have any effect on HTML. So it's only output that we would output to something that would make pages. A label we've seen in equal, and then a label we're going to see in an example in a minute, includes the number of observations in the listing and optionally gives it a label. The OBS equal label allows us to rename that OBS column to something else. We can also say inobs, which suppresses the output, the OBS column, so it doesn't even appear. The round we've seen earlier rounds a number to 2 decimal places, or we can specify some other number of decimal places. And then we're going to see an example in a minute where we can define how we can split the label that is going to appear in as a column name using a special split character. And finally, we're going to look at how you can limit the number of observations used by defining which is the first observation used and which is going to be the number of observations you're going to use. All right, and then some common statements for PROC print. We've seen this, and we're going to see tables like this. Whenever we do a procedure, we're going to have a similar table that specifies the statements so that you can sort of get them in your mind. But for PROC print, we have the var statement, the sum statement, and by, ID, and where. And that's sort of all lumped together because they're very similar as we go along here. For instance, the sum statement we have seen before, but you simply say sum and then the name of a numeric variable. And what that does is when you do the PROC print, at the bottom, it will sum up that column. So let's look at an example here, aprint1.sas. Open that up. And we see here we have PROC print, and we've added a few things to it. N equal number of observations is, that's the label we're going to use. And then OBS equals subject, so we're going to replace the OBS column with the word subjects. We're going to sum those 4 records, and then we have a title. So let's see what that looks like. First, on the left, we see that the OBS column is now called subjects. We see that the time 1 through time 4 columns have been summed. We see 1063.4, etc. And then at the bottom, we see number of subjects is, and then 50. So we defined that statement, that label, number of subjects is, and then it gives us the number there. So again, these are, we're just adding sort of things that you can do to make your reports more legible, more helpful to whatever you're trying to do. Now let's look at this last section, splitting column titles in PROC print. So here we have a PROC print, data sum data set, and we're going to define a split statement. So split, or a split character. In this case, split is equal asterisk. And we have a label statement there. We're going to create a label called inc key, which is subject ID, and then a bunch of lines. What that means is when you put the column label, say subject, go to the next line, say ID, and then underline it. And the same in age is age in, and then go to the next line, 2014, next line, underscore, as a sort of an underline. And then the final one, gender, we have gender, and then a blank, so it's going to have a blank line, and then the underscore. Open up a file called aprint3.sas, and we have a number of things going on in this program. So we're doing a PROC print of some data called trauma. As we mentioned earlier, we have this first obs and obs variables in here. First obs 11 and obs 20 means for it to only use observations 11 through 20. And then we're defining the split character. We're defining the way that the OBS label is going to be used. Observation, go to the next line, number, and then use a little underscore thing there. And then we have labels for several other variables there, as you can see, all defined. And the reason for that is we want to create an output that looks a little nicer. So here's the resulting output, and we can see again that the columns are much nicer looking than what SAS would have used by default. I want to mention one thing here that you may not have noticed before, but notice here that if SAS sees that it's a number, it's going to right justify both the label and the information. If the data in the column is text, like gender, it's going to left justify both the name and the data. So you can sort of easily tell if so for instance, in this case, this subject ID is considered a number. We probably most likely wouldn't want it to be a number, but no harm right here. But we can tell the difference between a number and a character column by how SAS formats it. All right, let's look at some more common system options. In this case, we're going to define some options that help us control how our data may be output. And the option statement is options and then one or more options. So for instance, if we say options orientation equal landscape, you can imagine what that means is if we're outputting to Word or PDF, we're outputting to what we're planning on printing in landscape mode. Here are some options. The one that we just mentioned, the first obs and then through a certain observation. So we'll see that we saw that in an example. The year cutoff we haven't seen. It specifies how a two-digit date will be interpreted. For instance, if we say year cutoff equal 1920, and we have this data here that specifies a date of 19, it would be considered 2019, while the date for 21 would be seen as 1921. So it splits the data, because oftentimes we have things that run more than 100 years. The default year cutoff is currently, as of this recording, is 1926. However, it does change, so you may need to check on it. For instance, in SAS through SAS 9.3, it was set at 1920. So that changes as time goes on. A little side note here, if you're creating a date variable, always use a 4-digit date, because it helps solve this problem. And if we had done that many years ago, we would have never had the Y2K issue that came up some years ago. Other options are PROGSIG, defines the number of decimal places used to report p-values. The line size and page size has to do, again, with if we're outputting to Word or PDF, how many lines or how many characters are on a page. We can, SAS normally outputs a page number on each page. We can suppress that with no number, suppress date with no date. We mentioned the option for orientation, and we can cause SAS not to center the title, and instead it'll left justify it. All right, let's look at this example 5.9. Open up the file called sysobs.sas, and this is going to set some of these options and show you how it works. So we're going to say options first obs equal 11, obs equal 20, and then just do a regular PROC print. And then we're going to reset it. I'm showing you this because this is good practice to go ahead. If you use this, again, the reason is because once you set this option, it's going to remain for however you're running SAS. So if I happen to do another PROC down here that I didn't want it to apply to, well, SAS remembers it, so it's only going to use the variables, the observations we had defined earlier. So you need to reset it so you don't accidentally do an analysis on a limited data set. Okay, so this is the result we get. We can see now that it goes from observation 11 through 20. So whatever PROC we do from now on, unless we reset it, it will only look at records 11 through 20. All right, so that's the end of this chapter, and hopefully you will continue to chapter 6 to where we'll start getting into advanced programming topics. Thanks for watching. If this has been helpful, please subscribe and like this channel. Thank you.